Unit testing involves testing individual units of code. A unit can be a single procedure, function, or a small body of code. In procedural programming, a unit might be a function or a page of source code. In object-oriented programming, a class is often considered a unit. The definition of a unit can vary by organization. Boundary value testing focuses on the edges of input domains. It is a specification-based testing technique. This method helps identify test cases by examining the functional nature of a program. There are 4 variations: normal, robust, worst case, and robust worst case boundary value testing. Figure 5.1 illustrates the input domain of a function with 2 variables. Boundary value testing identifies errors that occur near the extreme values of an input variable. The basic idea is to use input variable values at their minimum, maximum, and nominal values to identify potential faults. Boundary value analysis can be generalized by the number of variables and the types of ranges. For example, in the nextDate function, variables for the month, day, and year are considered. The method involves holding all but one variable at nominal values and testing the remaining variable at its min, min plus, max, and max values. Boundary value analysis has limitations. It works well for programs with independent variables representing bounded physical quantities. However, it may not be suitable for variables without a true ordering relation, such as car colors or football teams. The physical quantity criterion is crucial for effective boundary value analysis. Robust boundary value testing extends normal boundary value testing by considering values slightly beyond the maximum and minimum. This method focuses on exception handling and is particularly useful for strongly typed languages. It helps identify how a program handles values outside the expected range. Worst-case boundary value testing examines what happens when more than one variable has an extreme value. This method generates more thorough test cases by considering the Cartesian product of the variable sets. It is particularly useful for physical variables with numerous interactions. Special value testing is an intuitive and ad hoc form of functional testing. It relies on the tester's domain knowledge and experience to identify hot spots for test cases. Despite its subjectivity, special value testing can be effective in revealing faults that other methods might miss. Examples of boundary value testing include test cases for the triangle problem. For each side, test values are chosen at the lower and upper bounds. The cross product of these values generates a comprehensive set of test cases. This method helps identify potential faults in the program's logic.